Hello everyone, I'm Prof.Lee. So today we're going to learn about the chemical file formats and SMILES. And this is our first official class of this semester of computers in chemistry. Okay, so let's get started. And how to represent a molecule as a computer readable form. So the subjects we handle in chemistry are molecules. Molecules are actually, actual materials. I mean, they exist in real world, right? But when you want to handle them in computers, when you want to, store them or calculate something and store informations about molecules, then we need to represent them as files, as you know, right? So to handle molecules with the computers, then molecules should be written as some kind of file, such as, let's say that we generated, so we'd like to save information about of benzene molecule, then we can save it as a benzene.mol, just like other files you use in computers. Then there are many file formats to save molecules with computers. So they are called as chemical file formats. So the chemical file formats can be thought as a way to represent the 3D structure of a chemical as a text file. So usually they are text files. Not necessarily have to be a text file, but mostly, in most cases, they are written as a text file. So the chemical file should contain the following information of chemicals, generally, so not necessarily also. So the first, most chemical file formats contain information of 3D coordinates of atoms, and also it contains bond information. So bond information means which atoms are covalently bonded, connected. And also, sometimes it contains information on charges. What are the net charges or what are the partial charges of molecules or atoms. The most widely used file formats are the following. So the first one is MDL mol format, and the second one is Sybil mol2 format, and the third one is XYZ format, and the fourth one is the PDB file format. So today we're going to talk about the characteristics and the differences of all of these file formats. So the file format means, in other words, they are called as extension, right? Extensions. So if a molecule named ABC is saved in the mol2 format, then the name of the file will be abc.mol2, right? As you save something, just like as you save other files in your computers. And the picture on the right side is the example of a mol file format. So then let's look at the detail. So first, I'm going to talk about the mol file format. So the mol format was first created by the company named MDL Information Systems. So it is often called as the MDL mol file format. So the mol file format generally consists of 4 blocks. So the first one is the header block, and the second one is the atom block, the third one is the bond block, and the fourth one is the property block. So the header block contains the title and the name, title or the name of a molecule. And the following block is called, and this part is called atom block. And the following block is called bond block, and it ends. So actually, so this example file represents this molecule. So this molecule is represented like this. So let's look at the details of a mole file. So let's say that we save the information of this L-alanine as a text file in a mole file. Then the first two lines, these lines have the names of molecules. So these lines represents the name. And after that, there is a blank line. There is a blank line. And here is a called as a count line is following. So in the count line, here the number 6 means that the number of atoms, and this number 5 means number of bonds. And the following information is about the 3D coordinates of atoms consisting this molecule. So here the first column is about the x coordinate, and the second column is about, it represents y coordinate, and the third column represents z coordinate of each atom. So as you must have learned from the mathematics class, so we can represent the 3D space in a Cartesian coordinate with x, y, z axes, right? So these are the coordinates written in x, y, z coordinates, and the units are angstroms. So the unit is angstrom. So this means that the first atom is located at minus 0.6622 and 0.5342 angstrom position on XYZ plane. And the fourth column is about elements. What element does this atom correspond? So this is about the element. And the following blocks contain some additional informations of atoms, but we are not going to all the details in this class. So all you need to care about is the first 4 columns. And the following, and after the atom block, so we're going to talk about the bond block. So the bond block contains the information about which atoms are covalently bonded. So it's about the covalent bonds. So so this block contains information on covalent bonds. So bond information has the, so let's look at the first line. So this means that the first atom and the second atoms are bonded by a single bond. And the second line means that the first atom and the third atoms are bonded with a single bond. And let's look at this line. And the second atom and the fifth atoms are bonded by a double bond, and so on. So this one, so bond block contains information of covalent bonds. And the following block, so here these are the property blocks actually. These are property block. So the property block contains information on molecular information, so molecular properties, physical chemical properties. So let's look at the first line. So the first line actually CHG indicates it's about the charge. So it means charge. So the first line saying that the net, and after that here the number 2 comes. So here the number 2 means that the net charge of this molecule is plus 2. Sorry. So this one means that there are 2 charged atoms. There are 2 charged atoms, and the following information is about the first atom is number 4. So the atom number 4 has net charge of 1, and the atom number 6 has net charge of minus 1. And the next line contains information of isotope. So here the one atom is an isotope, and this indicates that the atom number 3. Let's go to the atom number 3. But atom number 3 is here, right? This is the atom number 3. And And it indicates that the atomic mass of atom number 3 is actually 13. But if you look at this line number 3, atom number 3, then it's carbon. And as we know, the usual carbon has a mass of 12, right? But the 13 means that, it's an isotope. Okay? So let's look at another examples. So as we mentioned, first in the atom block, the first 3 columns are XYZ coordinates. Unit is in angstrom. And the 4th column is atomic symbol, so it indicates elements. And the following columns contain additional information. So each column has specific meanings, but these are not used very often, so we're not going to the detail of this block. And if you look at the bond block, and the first column is the first atom, and the second column indicates the second atom, and the third column indicates bond type, whether it's a single, double, and the 4th column indicates about the chirality, stereochemistry. So then how the chirality is represented in mole file format. So if you look at this fragment, and if you look at this molecule, they have different chirality, right? There's a stereocenter. And in the mole format, the chirality, if you look at this line, there's a number 6, right? So here the 6 indicates a dashed bond. So the dashed bond means like this, right? So the 6 indicates that this hydrogen is bonded through a dashed bond. But if you look at the example on the right side, so the 4th column, so if you look at this line, so the 4th column has number 1. So the number 1 indicates a wedged bond. So the wedge is called like this, right? So it's something like this. So this is called wedged bond. So if you wonder what this wedge means, so if you don't know about the word wedge, then you can look up the dictionary. A dictionary. So anyway, so by using the 4th column, so the numbers in this 4th column indicates the stereochemistry of a bond. So this is how mole format saves the information of the whole molecule. And the second popular file format is called Mol2 format. This Mol2 format was also created by the company named Tripos. And the characteristic of this Mol2 format is that it explicitly specifies atom types. So for example, C.Al indicates this carbon is aromatic carbon, or C.3 indicates that this carbon is sp3 carbon, and so on. So let's look at the example on the right side, and please ignore this first column. This is just a line number, so this is not actual contents of a file. So if you look at the example on the right side, the characteristic of Mol2 format is that it starts with header. So header always starts with @ and Tripos. So this first block is called as a molecule block. So the molecule block has, the first line of the molecule block has the name of the molecule. So this is about the benzene molecule. So one of our favorite friends who majoring in chemistry, for chemists. So the title is benzene, so it's a name. But you can write anything here. So it doesn't have to be benzene. So you can write your own line and so on. And the second line contains number of atoms, This one has a number of atoms and number of bonds. And the next line contains some characteristics, and the fourth line generally indicates charges, net charge of a molecule. But as we all know, a benzene molecule doesn't have any charge, so the net charge is 0, so it writes as no charges. And the following block is about the atom block. So the atom block contains multiple columns, and the first column indicates the atom index, and the second column indicates name, atomic name. And the following columns are about the coordinates. So this one is an x coordinate, y coordinate, and z coordinate, as you have the same as the mole file. And the units are all angstrom in angstrom. And the fourth column is about the atom type. So this one is atom type. So the atom type indicates that, the first carbon is the aromatic carbon, and the second carbon is the aromatic carbon, and these atoms are hydrogens, and so on. And also another characteristic of the Mol2 file is that the final column has the information of partial charges. So we're going to talk about the details in the next slide. And the following block. Okay, let's delete these a little bit. And the following block is about the bond block. And the bond block contains information of covalent bonds. So the first column is a bond index, bond indices. And the second column is the first atom. And the third column is about the second atom, which is covalently bonded. And the final column is about the bond type. It's about bond type. So which indicates that the first atom and the second atoms are covalently bonded with an aromatic bond. If you look at this line, for example, 11th line, then atom number 5 and atom number 11 are covalently bonded with a single bond, and so on. So this block contains the information of which atoms are covalently bonded and what type of bonds they are bonded with. And let's look at another example of the Mol2 file format. And this is the example of another file, another molecule. So it starts from the header. This is the molecule block, and this one is the title, right? And this is the number of atoms. This one is the number of bonds. And actually, so the following two lines are unnecessary, but so you can write anything there. But conventionally, the fourth line contains information about charge. And the next block is about the atomic block. So the atomic block starts with this header, and the atomic block starts with atom indices, and these are atom names and XYZ, and these are atom types. And as you can see, the last column has information about partial charges, like this carbon has a minus 0.1356 E charge, and this carbon has minus 0.0410 E charge, and so on. So in the Mol2 file, we can specify partial charges of atom. So this is the biggest difference from the mol file format, and these are about the covalent bonds. And then, how many atom types are there in the Mol2 file? So actually, the atom types are defined by the company Tripos, and they defined their own atom types, and these atom type lists are shown here. So for example, sp3 carbon is written as a C.3, and sp2 carbon is written as C.2, and sp carbon is C.1, and so on. And also the aromatic carbon is C.Ar, and carbocation is written as a C.Cat, and nitrogen sp3 C.N.3, N.2, N.1, and so on. So by using this table, we can explicitly specify what kind of atom type does some specific atom has. So this is very convenient, and so many chemical softwares use Mol2 file format, especially for modeling or calculating physical properties. So you don't have to memorize all these atom types, but at least so up to here, so you can easily see that up to here, you can easily identify, which one is which. The only, the particular ones are like this one. So this one is a planar nitrogen. So the planar means that nitrogen sometimes can be plane, right? So on plane. And this one is a nitrogen amide, and this one is a nitrogen sp3 positively charged. Let's delete a little bit. Yeah, this one is a positively charged, right? So these are some particular molecular types, atom types. Okay. And next time, let's talk about XYZ format. So the XYZ format is a very popular format, mainly used by the quantum calculation softwares such as Gaussian or QChem. And so we're going to practice Gaussian during the class. So, but the Gaussian is a very famous, quantum calculation package. XYZ format is rather simple compared to the previous ones. So the first line contains the number of atoms. So for example, so this is the example of benzene XYZ file. So the first line has the number of atoms. The second line is the title or name, which means that you can write anything you want. And the following lines so the first line has the element symbol, so atomic symbol, and the following numbers, as you can easily assume that, so these are X, Y, Z coordinates of atoms. So the biggest difference from the previous format is that the first column only has the symbols, atomic symbols. They don't have numbers. In usual quantum calculation softwares, actually the atoms are indistinguishable, right? As you can see, so actually, so carbon number 1 and carbon number 2 are actually, artificial, just for the convenience. But in reality, in quantum mechanics, the carbon and the carbons are identical, so they are indistinguishable. So actually, so all you can specify is actually the atom symbols. So that's why this, XYZ format is usually used for quantum mechanical calculations. And next format is the PDB file format. So the PDB file format is then what does the PDB mean? The PDB is the acronym of Protein Data Bank. So Protein Data Bank. So as you can see from the name, so this PDB file format is mainly used for proteins to save information of protein structures. So it contains rich information of proteins, and we may have a chance to talk a little detail about this PDB file format later. But the characteristic of PDB file format. So on the right side, this is an example of PDB file format. So as you can see, so they usually start with some keyword like header, title, author, remark, or secret, atom, and so on. And the most important part in the PDB file format, the most important file usually is the secret and atom lines. So the lines starting with this secret keyword contains information of amino acid information. As you must have learned from the biochemistry class, actually the proteins are chain molecules connected with 20 amino acids, different 20 amino acid types. So the secret line contains information of amino acids, and these are the amino acids. So the amino acids are connected like bees of a chain. And the atom section starts with the keyword atom, and this one contains the 3D coordinates of atoms. So, and as you can see, and the atom section has start with the atomic name, and so this is the atom name, and this has atom residue name, amino acid name, right? So PDB file format is mainly used for proteins, and the atom section of a PDB format has information about atom name and residue name and 3D coordinates. And by using this, they generally they are used to store the 3D structure of proteins. Okay, so far, so we have talked about the chemical file formats, and let's take a short break and let's talk about the SMILES representation.